Okay, so can you do like a 1 minute intro and then we can get started?
Sure. So I'm a senior at university studying for a FAANG interview coming up in a week from now, just trying to see where I'm at and see where I need to improve.
Okay, sounds good. So I'm not going to be pasting directly from LeetCode, so I'm going to give you some stuff. It's going to be a little bit more vague, and then you can ask whatever you want.
Sure.
Okay, so in this first problem, you're given a string and a word list, and I want to know if I can split this string using the words, and only the words. So basically, let's say I have a string like LeetCode, and I have words, um, leet and code, or then this is possible because I can break it like that. If I didn't have both of these, then it wouldn't be able to work. And so I just basically want you to return yes or no.
Okay. So again, for my input, I'm given like some sort of a target string, right? And then I'm given a list of strings. And as output, I'm just saying either yes or no, the target string can be made by splitting, or yeah, the target string can be made by splitting into these words. In other words, could I say that the target string can be made by concatenating these words? Would that be accurate?
Mm, yes, I guess. So yes, you can basically yes, so you can take a bunch of words in this array, combine them together in some way, and make the target string. Yeah, that makes sense.
Okay. Um, cool. So I think that seems all right. Just a few questions. Could the target string be null?
Mm,
In other words, like target is just an empty string.
yes,
Okay. And if it was none, could I say that that's possible by taking no strings?
yes.
Okay, so I can also just say that an empty string by default is just like a true.
Mm,
Okay. Could there be no strings in the words list?
yes.
And in that case, that would be false.
Yeah.
Okay. All lowercase?
Yeah.
Okay. Could there be letters, special characters?
So we'll just say only lowercase alphabetic letters.
Okay, it seems to make sense. So let me think about how I'm going to approach this. So, like I said, we could look at this as splitting the string into different groups, but I kind of like this as taking these strings and instead trying to make the target. So in this case, I know that I could have a valid end string if I took like leet and then added code onto it, but I could also have maybe a situation where I had something like this, and I could take leet and co and d, and I'm also assuming order doesn't matter, right? So if I had something like this, I could take leet and then co and then d, right?
Yes.
All right. So there's basically a couple options that I have as I'm trying to make the string. I can either take the word at index I for I in range len of words. I'm gonna call the length of words n,
Hmm.
right? Um, this is kind of sloppy, so I can just take any word in words, or I can skip the word. And what I want to check is after all possible combinations of taking and skipping,
Hmm.
can I make the target string? Is this making sense?
Yeah. So basically, you're saying I need to take every word in words, and because they need to be like so in this case, for example, like leak code works, but this doesn't, right? So you're gonna say you're gonna take every word in every different order possible, and then combine it and see if you can make the target string.
Yeah, absolutely.
Okay. So that does make sense. So what would be the time complexity of that?
So if I'm just trying to take all of these words, that means I'm considering every possible combination of these for the target string,
Mhm.
which the combinations is going to be 2 to the n, correct?
Um, so
Um,
so you can actually, I guess you didn't ask this, but you can have a word multiple times. So for example, this would still be valid.
right.
So
Um,
in that case, you can basically take a word like a lot. So I don't think this would be like very efficient because like you don't know what word is first and you can keep taking it for a very long time and you have to get all combinations. So imagine if like our string is really long and our words are really short, like and there's a lot of them. You're gonna have to like and you're not really doing an early return or anything. So like imagine we just have like every word is like a 26 character or sorry, one character and the string is like a million, like that would just get ridiculously long. So is there anything that we could do better instead of doing this all combination thing? Because yeah, we can have a huge word list or a huge string and then it would be like 26 or whatever. Like we can use every word a billion times in any order and stuff like that.
right. So what I'm thinking is we could pretty much answer the question of like given that we're at a certain position in the string, what elements can we add onto it to continue to find the target string?
Hmm.
Essentially trying to break this down into subproblems and solve it dynamically.
Hmm.
So, like in this question, for example, we know from the start, okay, we can't take DE or CO, but we could take LEET.
Hmm.
Okay, now we know the problem taking LEET to start. Now we could take LEET again, that wouldn't work. We could take, that wouldn't work. Okay, we can take CO, then we can take DE, then we can take DE. And maybe if we're in the situation where, like, say I have this smaller string D, which is going to cause a lot of problems because we can take this any number of times.
Hmm.
I might get to this position where I've like taken two strings, and then I can either add the DE or the D. But if I just add the D, now there's no possible way to continue from here. So we could
Hmm.
break and return. And assuming that we're caching this point here, this could be a really efficient lookup to get back to where we were before.
Hmm. So can you
Is
break
that
down the time complexity for that?
sure? So in this case, we again need to try all of these possible values. So it's going to be n times the length of the string, right?
So what is n?
And again is the length of words. So essentially
Okay.
it would be O of the length of the words
Mhm.
times the length of the string.
Okay. And so I understand why you have the length of the string, you have the length of the words. I think you're missing something as well. So you have
Yeah,
to do this like word comparison thing, right?
right. So if I'm at this position, what I'm thinking is like realistically, I'm going to pass essentially an iterator, like a value here. So we're going to start at the 0th index. And then if
Hmm.
we have lead, this is going to jump us forward the number of letters in here that match. Oh, but how am I going to check if all of these match?
Right. You need to do a string compare. So what's the time
Right,
complexity of that?
right. So the string compare is also going to be O of n, or I'm sorry, not n is an undescriptive. It's going to be the order of the size of the word, right?
Hmm.
So
So what would
it's
be your full
O,
complexity then?
O of length of words times the length of the chosen word. I'm going to call this word sub I times the length of the string.
Hmm.
Is that making more sense?
Yeah. And so one final question for you. So right now you are comparing like so you're basically saying for every starting index I will compare to every word and I have to do a string compare. And because I'll be caching these, this will be this. Is there any way we can make this more efficient?
Huh, that's a good question. Maybe we could try, well, I guess going backwards wouldn't make much of a difference because we're pretty
No.
much doing the same thing.
Like basically how
Um,
do we make the string comparison more efficient, that part?
oh,
Like the
that's a
rest
good
of it seems
question.
fine to me.
Um, maybe if we pre-computed the slices, but that doesn't make a lot of sense. That would probably bog it down. I'm honestly not sure here.
Okay,
I know
we can
that.
just if you don't know, then we can just move on to this. I think this is good enough.
Okay, but we'll just start with this for now.
Sure.
The main thing I want to do before I hop into coding is just define out my recurrence relation pretty
Hmm.
clearly. So I'm going to do this partly in code, but this is just me trying things out here. I'm definitely going to be changing this around.
Sure.
So I'm going to just call this can make at position with word. I get this is a little far out, but I'm going to optimize this later.
Hmm.
So I'm just trying to answer from this recursion, can I make the target string if I'm at the position I with the selected word j, which is pretty much going to be my index in the words array?
Hmm.
So my base case here is if I is equal to the length of the word, the target, I'm actually going to call it, then we can return true. That means somehow we made it to the end of this string, right?
Hmm.
But in another case, if I is greater than the length of the target, that means that we probably went out of bounds. I may not actually need this. I may be able to essentially like prune instead and avoid this, but I'm just going to keep this here for 8 now.
Hmm.
Okay, so again, I'm trying to see essentially if the current position we're at, or maybe it makes more sense to do it like this. Instead of passing the word here, maybe do I just enumerate through all of the words once I'm in this loop? Because I could just say, like, for word in words,
Hmm.
if target from, position I to the length of the word is equal to the word, then I can continue.
Hmm.
And if not, this is invalid. So I'd pretty much want to return false here. But here I'd want to say, like, the result is equal to can make at position I plus the length of the word. Yeah, actually, I think this makes more sense is if I don't try to pass an extra piece of state for the word I'm taking, and instead enumerate through every word, because we know we want to check all of them at each level, right? Like, is this making sense so far?
Yeah.
Okay. So I do want to just maybe check my slice bounds here, but I'll do that after I think through this a little bit more. And then I pretty much want to return. Oh, okay. So I can say res is equal to the result or can make, because I'm going to try and have this return a Boolean.
Hmm.
So in this case, if any position from here can be made, this will be set to true. And then if not, we can just kind of skip over this, right? We don't even need this check.
Sure.
I think this induction is looking okay so far. Um, do you think maybe I could go into just trying to code this up?
Yeah.
Okay. So I'm just going to call this solution. And again, it's going to take in a target word and then a list of words. So I have this induction that I'm trying to do here. So if I'm trying to return the final result, I should be returning can make at position 0, and then that should either return true or false. Again, if I is the length of target, that seems to make sense. I did want to think about pruning on if this was going to go out of range. So maybe I can just check if I plus the length of the word is greater than length of target, we can just continue. Like, this is going to be invalid. So then I can get rid of that check. Else, if target starting at I to the length of the word. Oh, that's not going to work at all. I need to go from I plus the length of the word. My only question here is if I need to add 1. I don't think so. But I'm going to just add a little comment here so I can look at this if I'm having issues. This should correctly check against the word. Then the result is either this, if I can make it there, and this is going to go over all possibilities. This makes sense, but we've done no memoization. So this is still going to like enumerate over every possible position. Would it be okay here if I used an at cache, or would you prefer to see me make a memo array?
I think you can make it yourself. Don't use the built-in.
Okay, so memo is just going to essentially be a dictionary. Now I could make this a default dictionary. For now, I think I'm just going to leave it how it is. And we're essentially just going to be parameterizing based on our position. So for the base case, do we need to consider this at position 0? I don't think so, because that's where we're starting, and then this should go all the way to the end, right? So all we want to do is, if we get in here, just check if memo to the I, return memo to the I, or no, I'm sorry, I got this wrong. If I in memo, return memo to the I, and then here at the end, we're just going to say memo to the I is equal to the result. I think this should work. Basically, we've already been here. We know if it's possible, yes or no. Oh, does that really help us if we just know if it's possible or not? Maybe I'm storing the wrong state in this memo. No, I think this makes sense actually, because if we get a possibility, it would then roll down. Okay, so let me just check this again. If we reach the target string, return true. If the value is already in the memo array, we can just return from the memo array. For all of the words that we have, if I plus the length of the word is greater than the target. In other words, if it goes out of bounds, we're just going to continue. Else, if the target sliced between I and I plus the length of the word we're trying to take is equal to the word we're trying to take, then we can add it, and we're just going to check if going down the path we can do that. All right, do you think maybe I could try and write out some test cases and see if this works?
Yep.
All right, so if name is equal to main, I'm going to do a couple test cases here. We'll start with the basic one, where we're going to say target is equal to leet code, and then I'm going to have the words equal to leet end code. I just want to print solution of target and words. I'm going to start with one test case just to see if this is like working as I intended. And if not, we'll take it from there. Local variable res reference before assignment. Okay, I think I never actually defined this res variable. I totally didn't. All I have to do here is just set it to a default of false, because again, if one of these is true, it'll flip to being true because we have this or here.
Yeah, I think you misspelled the call at 68 as well.
Oh, you're absolutely right. I changed the name of it, so then it got misspelled there. All right, let's try and run one more time. All right, I get back true, which makes sense. That should work here. I'm gonna try and just do like one of the simpler cases that we had here where I have like co and then DE. And then I'm gonna try and make a case where this just doesn't work at all. So I'm just gonna take out the DE here and see how this works.
Sure.
Oops. So I want to do target 2 here and words 2, then target 3 and words 3. Let's see what we got. True, true, and false. That seems to make sense. Looking at my code again, I feel like my induction makes sense. maybe there's an issue I'm missing, but it looks like things are getting checked correctly and making it to the true case. So I'm pretty happy with this.
Okay. Let's see. Yeah, so I guess you didn't test like the empty strings and the empty words. So before writing that, does your code handle that?
Yeah, so at the moment, I don't think we do. I completely forgot to do that. But let me just think about it. If we start at 0 and the word is 0, um, we are actually at the length of the target.
Hmm.
So that might work. Actually, I think that would work. It would return true.
Hmm. And what about the empty words?
The empty words, we're going to try and go through every word in words, and it's just not going to have any. So since we set res equal to false already, this should also just work.
Hmm.
Let
Yeah.
me double
You,
check this just by,
sure.
or sorry, go ahead.
Yeah, no, you can go ahead.
Okay. So I'm again just going to have like a words for, and I'm just going to put in like test. Check that this should work.
You need a list.
You're absolutely right. Thank you. Then we'll just do this one more time. And then the only difference here is that I'm just going to flip these two, and these should both be true. Something happened here. Uh-oh.
Never seen this before, honestly. Maybe run it again. What is going on?
Did I miss a bracket somewhere?
Mm. So what if we get rid of this? Does that fix it? You might have too many tests. Like I honestly have never seen this before.
Oh, that's weird. I think it really didn't like the empty string.
Oh, so I think I know what's going on. Or okay, do you know what's going on? Like what happened with the empty string? Like can you think about it?
Oh, okay. So we passed the empty string. It's gonna use the empty string as a word in words, and then it's
Hmm.
gonna try and just like keep adding the empty string on, which I think is gonna go forever.
Hmm. Yeah. Yeah, so it'll always say it's true and then it will just go to the same index forever. Okay. So
Uh,
another small thing. So you have code on line 68. Can you think how you can clean that up?
yeah. So this is usually how I do this, is I try to just like OR it. Oh, I could maybe do an OR equals here. Like I
Not
think
even the or equals, just think about what you're writing and think about if it makes sense. Like
so the
basically what's the
result,
goal of this problem?
the goal of the problem is just to, oh, well, the goal of the problem is just to return true if we ever make it.
Hmm.
So maybe we just break early and return true, right?
Hmm. So can you refactor?
Yeah, so instead of like having this result variable, I just try to get to the end. And if we reach this length, I should be returning true early, right? Well, no, that would make the function return true, which would then roll down. Um, so maybe instead of trying to say it's false, we just return true,
Hmm.
and then I'm kind of getting hung up here because I feel like the idea is that the truths should unwrap as we go, but I also really think there should be an easy way for me to just say like, okay, we hit it, we did it, let's break an end.
Yeah, well, so this thing at 67, if it's true, you can break an
Oh,
end, right? So
yeah, yeah, absolutely. So I could just say if we can make break, right?
break wouldn't work because now you don't have a result.
Oh, you're right, because now I need to just return true if we can make this.
You still need to change it a little because now you're still using result and you're not caching here.
Yeah, you're right. So here I would want to say memo to the I is equal to true,
Hmm.
and then I would just return true. Then in a case where this didn't happen, I'd want to return false.
Yeah, you need to memorize here too.
Oh, you're right. Man, now I'm getting sloppy because I'm trying to go fast.
It's
Because now
fine.
here I'd want to say false because we
Yeah,
never actually hit this true condition.
yeah. So one final question. So think about, do you need this memo block and why or why not on 68?
Hmm. maybe no, because, well, we say here if I in memo return memo I, right? So
Hmm.
essentially, if we've already hit this return, this is more helpful if we've already gone down a path and realized that it's already wrong. If we know we're right, this should roll out correctly.
Hmm. Yeah,
Yeah, so I
basically,
don't,
if you're right, you will never revisit because you just are done.
right.
Okay, cool. Okay, let's move to the next. So in this next one, we have a task runner system. Um, and these tasks can depend on one each other or one another. Um, and so basically, you're going to be given as input, and we can just make this simple. So tasks are going to be given by a number and the task that they depend on. So let me think about this actually. So let's actually change it a little bit. So you're going to be given n tasks, okay? And we're going to be given a list of dependencies. So this n tasks, if it's like 5, then we have 5 tasks, 1 to 5. And we're going to be given a list of dependencies. So for example, if we have like 1, 2, that means 1 depends on 2. Yeah. So you're going to be given this list. So maybe it'll be like, we can call this like dependencies or dep or whatever. So let's say we have this as like our example. And we want to return the min time it takes to run all tasks, assuming a task takes 1 unit of time, and we can run infinite tasks in parallel, provided their dependencies are done. So in this case, basically, because 1 depends on 2, one thing we could do is like in the first cycle, we can run 2, 3, 4, 5, which will take 1 unit of time, and then we can run 1. So this will be 2 units of time. And let me know if you
Okay,
have any questions.
I think this makes sense. So essentially, we have an arbitrary number of tasks, right? And we can think about each of these tasks as being independent, except we manually define some dependencies. So in this case, we say for 1 to run, first we have to run 2, correct?
Mm-hmm.
So then here, we know that 3, 4, and 5 have no dependencies, so we can just go ahead and run these. But 2 has to come before 1, so this happens in like a discrete time step before 1, right?
2 has to come, uh, yeah, before 1. That's right. Yeah.
Okay, so essentially, like the challenge here is managing the dependencies. Um, how do we know which things need to happen before others? And then since everything takes one discrete unit of time, it's really just a question of how many dependencies do we need to essentially like go through to uh, check all values, right?
Mm-hmm.
So this one, this one I've done more than a couple times. This is a topo problem in
Okay.
that the main issue we're going to have is trying to figure out how these dependencies relate. So if I can essentially understand where these dependencies are, then I can understand what the final result is. Um, I'm trying to think of how I would. I think the easiest way to do this would just be like to represent this as a graph
Okay.
and then try to go through all items where like each step takes 1 unit of time and then return the total number of steps, right? Like, does that make sense?
Yes.
Okay. Yeah, sorry. I was getting a little caught in the weeds before. So my basic approach here is I'm going to do a cons, which is like a BFS based topo algorithm.
Mm-hmm.
Then that's going to return me a topological ordering. And then I'm going to pretty much try to BFS through again to count the steps, or in other words, like how many times I have to do a level order traversal. to reach all nodes, or all nodes are equal to visited.
Mhm.
So I guess one of the key things that I need to ask about here that I didn't before is, can there be cycles?
Yes.
Okay, but in the case that there's a cycle, it's impossible, correct?
Mhm.
Because if we had a cycle, um, dependencies just would keep going back and forth forever,
Yeah. So
right?
if there's a cycle or it's impossible, you can just return -1.
Okay, so we'll assume if there's a cycle, we can return -1. Can these values be negative?
No. It's just
No,
you're given
yeah,
n and
that,
it's 1 through n.
oh, that makes so much sense, because each thing is just a dependency.
Mhm.
All right, I think that makes sense. Can I go ahead and start coding this?
So 1 second. So
Yep.
can you kind of walk through basically? So you said you're going to use a cons. Can you walk through what that would look like with the
Oh,
example I
absolutely.
provided?
So the basic idea of a cons algorithm is we want to take all of the nodes that have an in degree of 0, because that basically means that they have no dependencies. So
Hmm.
if we considered this graph, like 1 depends on 2, but no node essentially like feeds into 2, right? So 2 has an in degree of 0.
Yeah.
Um, Also, 3, 4, and 5 have an in degree of 0. These are all independent events, right?
Hmm.
But 1 has an in degree of 1 because 2 depends on it. I'm sorry, 1 depends on 2. So what's going to happen is once we process node 2, we're going to say, okay, we've processed this, so the in degree of 1 is now 1 less.
Hmm.
And all of a sudden, we're going to realize, oh, okay, so now node 1 has an in degree of 0, and we can add that into our queue. So this is where the BFS comes in, is we basically just have like a queue
Hmm.
that holds all nodes with an in degree of 0.
Hmm.
And as we pop from the queue, we update the in degree of the nodes. And in the end, if any nodes like still have an in degree greater than 0, we know there's a cycle, or there's some sort of, actually disjoint edges would be okay here, but we know there's a cycle and it's impossible.
Okay. So the main question I have is how are we keeping track of like the steps? So on line 119, you said we're gonna have a BFS. So I understand how you have a cons and you have a BFS and nodes, but how are you gonna actually calculate how long it takes to run everything?
Hmm. It's actually a good question, because normally in BFS, when I look at it as like level order traversal, it's essentially you
Yeah, like
loop.
what do you define as a level, I guess?
Right, right. Like here we would try and loop the length of the queue, because
Hmm.
if we think about it like this, right, all of these nodes start with an in degree of 0. We're
Hmm.
going to say that this is one level, right? So we're going to
Hmm.
process all of the nodes in this level. And then, like in this example, 1 would be our next queue. So that's our next step or level. Does that make sense?
Yeah, so you're basically going to do the cons BFS level by level, and you're going to chunk everything that can be run at the same time into each level, and then the result is like the number of levels you traversed. Is
Yeah,
that correct?
absolutely.
Okay, and then before you start coding, last question: what's the time and space of this?
Right, so we need to consider every node. So we also need to consider all of the edges that come off of these nodes, because we're trying to pop every edge, every in degree. So we're going to have to consider everything at least once. So I think this is O of V times E, right? Because we're going to consider every vertex and every edge once.
So is that v times e?
Yeah.
So you said you consider every vertex once and every edge once. V times e is, so you're a
Oh,
little bit
you're
off.
right.
Yeah.
So that's V plus E, because V
Hmm.
times E would be every edge for every vertex.
Yep. And then what's the space?
So the space, I'm going to need to keep track of a graph. So the graph is going to hold all of the vertex and the edges again. So space is O of every edge, sorry, every vertex plus every edge.
Yeah, I think makes sense. Okay, yeah, we can
Okay,
start coding.
cool. So again, I'm going to define this one as solution 2 and hope that I don't forget this later.
Mhm.
We're going to take in n, and we're going to take in a list of dependencies. So I want to start by building out my graph.
Okay.
So I'm going to say that my graph is a default dictionary. Is it okay if I use a default dic here?
Yeah, it's fine.
All right, so it's just going to be a default dictionary that maps to a list, and then the list is going to be the edges. So
Mhm.
it's node to the edges, right?
Mhm.
Now, are these are directed edges,
So what do you
correct?
think?
Yeah, absolutely, it would be directed because we have like a pure dependency here. Like dependencies don't go both ways; they go one way.
Mhm.
So I'm pretty much. I want to try and maybe make this a little bit more defined. This is specifically a dependency graph. So I'm going to say for um, UV in depths, because each one should have a node, we know that in this case, like node 1 depends on node 2. So in other words, node 1 has an integree of 1. So we want to say depth graph to the U, to the node coming in, dot append V. We need to compute V before we get to U. Does that make sense?
So the node is like the parent of the dependency, is that correct? Or the child of the
Right.
dependency? Yeah, okay. So let me just double check. So I said one depends on two. So I think
So like this would be 1 is U, and then V is 2.
okay. Yeah. Okay.
Okay, and then the other thing I need to know is the in degree, which I'm again gonna have. I'm actually gonna have a default dictionary that maps to an int here. So what it's gonna do is it's just gonna take in a node and map to the in degree of that node. Oops, what am I doing here? And then again, I'm gonna say for node in depth graph. So now I want to consider all of the nodes in my graph. The in degree of the node is equal to the length of the dependency graph at that node. Because in this case here, like U is a node, and then V is the value, right? And that's going to be of size 1. So we know that there's an in degree of 1 for node V. I want to just make sure I did my iteration out correct here, because by default, this is going to iterate based on the keys. And the keys are U, which is the nodes, and then I reference by referencing the node. Okay, I think that makes sense.
Sure.
Okay, so now we basically want to do our cons. So the first step is setting our queue. Um, so for we basically want to loop over all of the nodes with an in degree of 0. I could maybe do this with a list comprehension, but I'm going to start by doing it out and then maybe I'll clean it up.
Sure.
For node in depth graph, if depth graph to the node is equal to 0, I should say, actually, let me do in degree. If in degree of the node is equal to 0, wait, am I doing this right? I might want to do this just in n, right? Because there absolutely could be nodes that don't reach here. Okay, so it should default. Well, if it isn't in there, we default to an empty list, which is going to be 0. But then here I should just say for node in range n, so that we make sure that we're hitting all of the nodes. Yeah, that makes more sense. Okay. If in degree of the node is equal to 0, q.append the node. All right, now we have what to start with. Now we can just do our cons. While the queue, we're going to say that level, or go level order for I in range, length of the queue. The current node is equal to q.pop left. So we have the current node. Now we want to decrease the in degree, right? So we're going to say in degree to the current node, or no, that doesn't make sense. We want to say for neighbor in the dependency graph to the current node. Basically, for every dependency that this has, the integrity of that neighbor is one less, because now we've processed this node, so we can essentially act like we don't have it anymore. And then, of course, we're going to add 1 to our result variable, which should be the number of times that we have to go through this loop, and finally just return this result. Okay, I've written a lot of code here. There's a good chance I've made a mistake somewhere or another, so I want to just do a quick review and make sure that I don't have egregious bugs. So we have a dependency graph which should map a node essentially to all of its dependencies. Now I am wondering if maybe I set the wrong value here, right? Because we're trying to say for this node, which like here is 1, it depends on 2. But maybe it's better to say for node 2, its dependencies are blank, because we're going to start with all of the nodes of in degree 0, right?
Mm-hmm.
So we want to be able to map the nodes with in degree 0 to nodes that like have an in degree that's higher. Oh, so yeah, I think in this case, I actually do want to say for every node which is like a starter, its dependencies are these, right? So this actually maps out the dependencies correctly. Then, am I making sense so far?
Yeah.
For all of the nodes in range n, the in degree for this node is equal to the length of the dependency graph of that node. Does that make sense now? So like if I hit 2, oh, and this should also be, right? I'm assuming n starts at 1 and goes to 5, right?
Yeah.
So this needs to be 1 to n plus 1. Like node 1 is going to depend on node 2, but here we're going to say something different. Maybe, now I'm getting caught up. Now because I flipped this in degree logic doesn't quite work. Right.
Yeah.
So maybe it does make more sense to have it the other way.
So I'll give you a hint. The way you have
Yep.
it now is right.
Okay.
You can just calculate the in degrees in a simpler way. Like this doesn't need to be a dictionary, and then
Oh,
from
you're
there you
right.
can figure it out.
Yeah, you're right. So the in degree should just be a list.
Mhm.
And what we want to do is just for every node figure out what exactly its in degree is. So if I'm at node 1, how would I know what the in degree is? I essentially want to see how many times a dependency maps to it. So how many times is this a part of this graph U? Now I'm getting stuck again. Like, this is something I've done 101 times. Dep graph to the V, so that's the dependency. Oh, okay, I see how I do this. So I'm gonna say for every neighbor in the dependency graph at the node, and then I'm going to increase the in degree of the neighbor, right? So
Sure.
here, in degree of the neighbor is gonna be increased by 1. That's gonna do it for every, essentially, node in the graph. That makes more sense. Okay, this seems fine. Make a queue for every node in the dependency graph. This actually isn't as good. I want to again say for every node in range n, or 1 to n plus 1, if the in degree of that node is 0, then we add it to the queue. That makes sense. The rest is going to essentially count how many times we go over the level. Here we make sure that we traverse by the level, grab the current node. For every neighbor, or I'm actually going to change this to be for every dependency in the dependency graph, the in degree of that dependency decreases by 1.
Mhm.
Okay, I have a critical mistake here, which is that I don't ever actually add back to the queue. So if the in degree of the dependency is equal to 0, q.append that dependency, and then that will help us actually get all of the nodes here, add one to the result, and print the result. All right, I'm finally pretty happy with this.
Okay, feel free to run a test case.
Sure. So if the name is equal to main, oops, then let's go back to this first test case.
Yeah, I'll
And
just
say,
comment out this first solution because I think you have the name main thing already. So there
oh,
you go.
okay. Yeah, thank you. I'm just going to print solution 2 of 5 and then depths. And I'm hoping that the output here should be 2. Depths is not, oops, I did not define that correctly. You are right. Default dict is not defined. Okay, I just need to import this from collections. Let me make sure there's nothing else I imported here. I might also need to import DQ.
Mm-hmm.
List index out of range. Oh, okay. Yeah, I made a mistake here in that I didn't actually do this out. We should start with 1. And then because I'm doing my neighbors like this should be -1 because it's ordered 1 to n plus 1. Oh, and I do the same thing over here. So again, this needs to be the in degree of node -1. Do I do this again? Current node in degree of the depth -1, in degree of the depth -1. Right.
Yep.
Name Q is not defined. Oh, okay. I'm gonna call this Q just because it's a little bit easier to type out. Looks like I had that mixed up a little bit. In degree is not defined.
Yeah,
What?
you wrote the wrong name on 163.
Oops. And then try one more time.
I haven't seen that. Maybe just try running it again. I don't know what
Yeah.
the hell that is. Okay.
2. All right, that looks okay.
Okay. Anything else you want to test?
How am I looking on time? I'm thinking I'm like 45 minutes, right?
Yeah. So you have enough time.
Okay, cool. I'll define out a couple more. I just want to see if maybe I have like a chained dependency here, like 2 depends on 3. Now this should output 3. Let's see how that goes. Yep, and then I also want to just check if I have no dependencies. Is this going to handle that? So now the answer here should just be 1. Let's see how that goes. Yeah, it looks like those are running okay. Were there other edge cases I defined up here? Oh, what if I have a cycle, right? Oh, I did not check if there's a cycle at all. Okay. So here what I can do is pretty much do this after my cons is done. So am I storing anything here? All of the in degrees should be 0. So I can do a little quirky thing. If I can say if not all, I'm going to call it IDG for IDG in degree. And it should be IDG equal to 0. All basically does an iterator and just checks if all of the iterators evaluate to true. So here, this is a Boolean expression, IDG equal to 0, and I just do it for every in degree in the in degree list. And if this doesn't happen, I should return -1.
Makes
So
sense.
again, yeah, let me just do one more here where I'm trying to make a cycle. So then I have 2, and it's going to depend on 1.
Mm-hmm.
And that returns -1, just like I hoped.
Okay. Let's see. I think you covered basically everything. Okay, let me ask you, I guess. So, I mean, this is kind of a rare edge case, and it probably doesn't really happen. Well, what would happen if you have a dependency twice, the same one, and you don't have to
Oh,
change the code? Just
that's a good
think about what
question.
your code would do.
So if I already had that in degree, I'd probably, or if I already had that dependency, I'd try to add it twice.
Hmm.
Um, so adding it twice, since this is a list, it really would be there twice, and it would likely update my in degree to be even higher. So I don't think it would work. A way I could fix this though is maybe if I had this as a set so I could handle duplicates.
So I think actually when you decrease, it will decrease twice. So even though like you had it twice, if you decrease, it will decrease twice and it will still be fine. Does that make
Let me
sense?
think about that for a second.
Mhm.
Right. Oh, right, because we have every dependency and we enumerate every possible dependency. So yeah, you're absolutely right. This would decrease twice and still end up with zero, but it would
Mhm.
maybe mess up my time complexity a little bit if we had a really weird input.
Mhm. So one small refactor we could do with the last couple of minutes is think about how can we get rid of the 141 to 143 block and just do this in the one above? Because you were trying to figure out how do I do this, and this was like unnecessary, basically.
Yeah, you're right. So I do want to know basically for all of the neighbors in this dependency graph, their integrity should increase by one. So I think I could do this as some sort of a list comprehension.
I meant like so imagine this goes here,
Yep.
here. What can you do in this loop?
Oh, yep. You're
Yeah.
absolutely right. So
Okay.
here we know that V is gaining an edge. So I can just say the in degree of V plus equals one. But again, because we have this indexing, it needs to be V minus one.
I think it's actually you, but yeah.
Would this be U? Oh, it
Yeah.
totally would be because U is the node that's mapping to V.
Yep.
I
Okay.
just want to check that still works. Yep.
Yeah. Okay. So I think we can stop here. We're right at time. So how do you think you did on this one? And what do you think you did
So
well? What do you think you need to improve on?
I think I did better than last time,
Mm-hmm.
but I'm noticing that I'm still making one of the same mistakes that I made last time, which is just overcomplicating things. There were a lot of places here where I was like trying to think, oh, okay, how do I do this basic thing? Like, how do I check that this word is the same at this slice? And I was getting way too lost in like indexing.
Mm-hmm.
I think I came to the solution pretty well. My explanations were a little hand wavy, but I was trying to be like clear and efficient.
Mm-hmm.
Um, the number one thing that like I feel like I keep making mistakes on is that I just make stupid errors
Mm-hmm.
and then maybe pick up on them in one place, but don't pick up on them everywhere. Like maybe it's an error I've made more than once. That more happened to me like on this second question where like I either misspelled something or like I subtracted one from the dependency somewhere, but then not somewhere else.
Mm-hmm.
So like all in all, I think I came to the solutions pretty well, but I'm still just having trouble doing some like kind of basic things, which I find kind of embarrassing because like I mentioned it, like I've solved a ton of topo problems before. Like the
Mm-hmm.
moment you started explaining question two, I was like, okay, topo problem.
Mm-hmm.
But then like I started struggling building out my dependency and in degree list, which again, this is something that I've done 100 times. Like I should be able to do this in my sleep.
Mm-hmm.
Um, but I had way more trouble than I should have.
Yeah. So yeah, so basically I think you did quite well as well, better than last time. I think last time basically I gave you a question where you didn't know the algorithm. This one, for example, if you've never done a topological sort, like you're not going to do it probably realistically off the top of your head. And you can kind of see why. Like even if you've done it, it's complicated enough to where there's still mistakes that can be made. And Dijkstra's is kind of similar, where like even if you haven't done it, you're probably not going to come up with it unless you're very, very good at other stuff. And even if you have, it's still hard enough for most people where they'll still make mistakes. So I'd say for the first one, so I wrote is you restate the problem, you asked about the constraints, and you basically covered everything, I think. You asked like a ton, which is good. Like, can you have uppercase? Can you have lowercase? Can you have all this stuff? And yeah. Uh, and then yeah, you mentioned a backtracking approach, and I pushed back on that, and then you gave me a better one, which was fine. And then your time complexity was a little bit off. I think you forgot the word comparison. So once again, I think I usually mention this to people. I would make variables for what's what, because if you say like n can be anything. So I had to ask you what's n. So I would just clearly say like, or write it to where you have it on line 10 like right away. Um, because then I know exactly like what you mean. And then let's see. Yeah, I think I wrote you had some mistakes in like your pseudocode thing, but then you ended up fixing them on your own, so that was good. And I think it's totally fine to have some mistakes and then like reiterate and like fix it. And then as far as your code, yeah, so you talked about your writing, use meaningful variable names. Your code is pretty good. Yeah, the only small things basically here I think was just like how do you make your code cleaner? And so I pointed out some like refactors you could make, but then you figured out like that stuff. So it would have been good if you did that yourself. Because yeah, that res thing didn't make any sense because it's just like you just return right away and stuff like that. And then I asked you to make a cache because I was like, can you make a cache? Can you make it correctly? All that stuff. You know, maybe people will let you use that cache. I mean, if we did like two DP problems and you made the cache correctly in the first one, then it would be fine to uh, do it in the second one. But anyway, so then, so I think that like basically your weakest thing was just coding and mistakes, but overall I'd say this was like a 4 out of 5, so like a solid higher in my opinion. I think your communication was quite good. Your testing was quite good. You covered. I think the only thing that you missed in the testing was you didn't cover the empty inputs, but it worked for them anyway, so it wasn't a huge thing. Then for the second one, you also restated the problem. You asked about basically edge cases. You didn't ask about the duplicate dependency, but that's kind of rare, and your code handled it. Yeah, you knew the topological sort right away, but I was like, this is the kind of problem to where even if you know the algorithm, it's still fine to do this problem because it's hard enough to where you can still make mistakes. Like if you knew it was a sliding window and it was a simple sliding window or something, I'd just be like, let's skip. But this one is like complicated enough to where we can still keep going. And then you basically had a pretty clear solution. I think you asked, can I start coding before I really knew how you were going to count this like step thing. So I asked more like in more detail, like how would you do this? And you explained it pretty clearly. So I had a very good idea what you were going to do. And then I think your weakest thing here was coding. So I wrote down 5 or 6 errors, and you fixed almost all of them. I think you didn't fix the one with the cycle thing until you started testing, but you figured out in the testing. But yeah, ideally you have less errors as you code because some things are like I don't really care, right? If you forget an import or you forget a name, like fine. But if you have like off by ones in a lot of places, and then you have like actual logic mistakes, like your graph was like wrong, you had to like swap it. Your in degree was like off by one and some other stuff. So ideally, I would try to make this cleaner, and then that way you don't have to go and debug like 6, mistakes. And as far as like, yeah, you've done it in your sleep and stuff. I mean, I guess during an interview, hopefully you see that like this is a mock. So during an interview, people are usually more stressed out and like don't forget basic stuff and like all that stuff. So I think that's your main. Like I think this was quite solid, and I'd say the second problem was also like a 4 out of 5, where it's like a solid higher. Like the only stuff you could have done better was, I think you said your time complexity was v times e, and I had to tell you to fix that. And then your code had some bugs, and some bugs you didn't notice until you wrote tests. So basically, if you could run through your code with a few less mistakes in the future and like just code quality improve a little bit more, where I had to point out to you some refactors and you could come up with those yourself, I think that would be like a strong hire. But either way, I feel like for like new grad, I think this is like quite an easy a higher decision in my opinion. We did 2 decent algorithms, and you basically did it like pretty quickly, and you had good test cases and like everything worked. So I'd say this was definitely better than last time. And the main thing is just like as long as you know the algorithms, I'm pretty confident you can like communicate and figure things out pretty quickly. The only thing you have left to work on, in my opinion, is just like code quality. So I would do a lot of like get a solution, put it into an LLM, see how you can make it look cleaner. And once you do that enough, then you know like, okay, this is how I can like optimize all this stuff. I think that's basically where you're at right now. So yeah, hopefully that's makes sense.
Yeah, that makes sense. Um, the main question I have with that is I have been trying to do things like for more array-based problems, learn like a lot of iter tools. Like down here, I tried to do this all to make the edge checking a little bit cleaner.
Uh-huh.
I guess my main question is, what advice do you have for practicing how to like write your code right the first time? I feel like I make a lot of errors as I write.
Um, how to write your code right. Okay, so basically you're saying like I want to be able to write this thing and just have it run right away. I
Yeah, I
think
guess.
partially that comes with doing enough questions. Secondly, it comes with like so you want to think like in your head like what am I doing? So you're like okay, I have to make a graph. I have to make an integrity thing, and then like what depends on what. So like you have to get this part correctly, and then the best thing honestly for having your code work the first time is having logic that's very easy to understand. Like once you start complicating your logic, it gets kind of hard to track. So like a really common thing people do that especially like out of like a boot camp or new grad or whatever is they have this like nested if thing, and then they just have like this like chain of nested ifs, and I don't even know what the hell they're doing. So as long as like you can keep your code like modular and clean, and it's very easy for you to understand what you're writing, then the chances of like it working right away go up, right? So it's kind of like don't dig yourself into a grave of like super complicated stuff, and then it will work more often than not. So I'd say that that's like probably the best thing is just like take something that you wrote that was not super clear and make it more clear. And you keep doing that, and then like hopefully that makes sense. Like basically, the simpler it is to read, the more likely it is to work. And then I
Yeah.
usually just do refactors. So usually, like I said, when I have a solution, I'll just feed it into an LLM and say like, "Can you make this better?" And then sometimes it will, sometimes it won't. And then see like what are the things you did that could have been cleaned up. So for example, this in degrees thing that you had, you had a dictionary and then you had like three loops or something. And then you were like, oh, but what if the node doesn't exist now? So maybe you did that, right? And you got something working. And then you feed it into an LLM and it's like, oh, use this in an array and it's better. And you're like, oh yeah, that's a great idea. So you take these like small fixes and then you use them in the future and then like things will get better. The other thing is for a lot of simple algorithms use templates. So for example, for binary search, I use like one template for that works for like everything. For sliding window, I use like one template that works for everything. So try to make templates for the really common stuff. It's like this is how I write this algorithm. And then that also eliminates a lot of like mistakes. But the other thing is you don't want to be so you don't want to get into the habit of being too like pattern matchy because if I ask you a cons with like some twists, you still want to like have enough bandwidth to be like, okay, with these twists, this is what gets affected. Even though I'm using my templates, like uh, I know what I need to change to make it work for this, right? And so some common things is like, have you done like union find?
Yeah.
Yeah, so for union find, I might ask you like what are the number of components or some other like twist on a union find. And you need to know how to like tweak a union find to match this thing. So the same thing for like these kinds of things. Like I can ask you like, okay, how long does it take? Give me an optimal like task sequence. Maybe instead of doing maybe instead of like giving me how long it takes, actually return an array of like all the tasks that you run in each step. And so you should be able to know like how to modify your algorithm to do all these simple things. But yeah, I think like that just basically comes with doing enough problems, and then ideally try not to rely on just like I'm just gonna run something, I don't know if it works, I'll just like run on LeetCode 10 times until it works. So you can like write something, you can walk through it, you can find all the errors that you can before, like basically try to just like find all the errors yourself, and then when you run the code, hopefully it's just syntax, not like actual logic stuff. And if you do enough, then yeah, you'll get better at it. So I guess yeah, the main two things is decrease code complexity and then look through your code and don't just rely on like leak code solutions for or leak code running for getting all your stuff, if that makes sense.
Yeah, that makes a ton of sense. I've personally been trying to like simplify my code because I'm like having this philosophy of the least number of lines I write, like the least chance I'm gonna have that there's a bug. So definitely gonna keep trying to apply that. I guess the only other question I had is what should my balance be between like communicating and asking questions without it seeming like I'm trying to be clingy or like get answers from the interviewer. Like there was a few times where I said things like, I'm thinking about this in my approach, like, but does this make sense? Like, am I on the right track? Is that too much?
So I would say I didn't feel like you were too like, so I wouldn't say like I'm thinking this like or yeah, basically what my approach is like I would say what I want to do clearly. I'd say like this is what I think is right and here's why. And then I'd be like are you good with this? You know, so try not to like ask them to double check your work, but be like this is what I'm thinking, like, you know, can we move forward? And then usually, if they don't like what you did, then they'll give you a hint, like what I said for the first one, just like, oh, I know you did this, but I think you can do better, something like that. But you don't, yeah, you definitely don't want to be in like every step. You're like, I'm doing this. Is this right? Is this right? Is this right? Is this right? So you want to just like clearly state, here's what I'm doing. Here's why. Uh, can we move forward? Something like that. And I think
Okay,
that
that makes
works in
sense.
software engineering as well, where like, you know, let's say you have a manager or product manager or whatever, you don't want to be like just give me stuff to do or give me an idea. You want to be like, so here's what you asked me to do, here's how I think I'm going to do it, here's why I think it's good. Now if you have any pushback, let me know, or I'll do this. And it makes like their job easier because they don't have to like spoon feed you all the time, and then usually you'll have good ideas and they can usually just say yes and move on. So same kind of thing here. You want to come up with the stuff yourself, but you also want to give them room to like push back. Yeah, and you don't want to be too like hand holding and whatever. So you basically just state what you're doing and why, and then see how that goes.
Yep, okay, that checks out.
Okay, cool. All right. Well, yeah, I think you're quite well prepared in my opinion. So yeah, let me know how it goes. Hopefully it goes well.
Awesome. Thank you so much.
Okay, cool. See you.
See you.